We now demonstrate how to use SPSS to run the variable selection procedures for multiple regression in this heating cost case. So far, we have established different multiple regression model for this heating cost case, but we do not know which model is the best. So we are going to run the variable selection procedures in SPSS to figure out which model is the best for us. So let's call the analyze regression linear. We have the cost as the dependent variables. And at the same time, we are going to pick temperature, installation, age, garage, and the interaction effect, temperature times installation, into our independent variables. So far, we have used the enter approach in the past to generate multiple regression models with all independent variables. However, today we are going to try different approaches. We are going to try stepwise, backward, and forward. The remove approach is a special function in SPSS, which compare the enter regression model and the model without any independent variables. This actually is not very useful for us. So we are going to focus on stepwise, backward elimination, and forward selection. And let's try the forward selection at first. Before we run, we can change some options in the SPSS. By default, we have 0.05 to enter a new variable into the model. If you like, you can change the standard, but by default, 0.05 is a good number. So we are going to keep it. And we are going to say, OK, to generate different multiple regression model. As we can see from here, SPSS enter temperature at first, and then it enters the garage, and finally it adds insulation, and the regression stops. So it means we have three different kinds of multiple regression model 1, 2, 3. If we look at the model summary, we have 0.845 adjusted R-squared value for the last model. Compared to the previous two models, we can see that the last model is the best and has a standard error of 41.6. Okay, so let's look at the ANOVA. It looks like every model has a good significance levels for this entire model, especially for the last one has the highest F value. But overall, all this model give us a goodness of the fit. Let's look at the coefficient table. We can see the p-value for all these different models. Let's focus on the last model, the third model. The p-values for all independent variables actually are very low, below 0.05. So it says that all independent variables are significant for this model. So we can also have the information of the variables included in every model. In the last one, we know that the age and the interaction independent variables, temperature, insert is included actually from the model. So this gives us the information about the final model that SPSS chose for us. That is, we have the temperature, garage, and insulation. Okay, so this is the model selected by the forward selection. So how about the other approach? Let's call the analyze and try regression, linear. We are going to try stepwise approach now. Stepwise approach allow addition and removal of variables in every single step. So we are going to pick stepwise. The options give us 0.05 to enter a new variable and 0.1 to remove a variable based on the F statistic. So these two values are default value used in SPSS, and we are going to keep it as it is, and we are going to run OK. Let's look at the model summary. If we look at the model, the variables, we find that actually the stepwise approach enter temperature at first and enter garage the second, and then at insulation the third. It basically gives us the same models as them in the forward selection approach. And of course, because of that, we have all the same coefficient information and also the excluded variable information in the stepwise procedure. So again, the stepwise approach gives us the same outcomes like that in forward selection. Now, let us try the backward. We are going to pick a different approach now called backward elimination. For analysis, again, in the option, the default value to remove one variable is 0.1 p-value for the F statistics. So let's try this, and we are going to say OK. Now let's look at the output of the backward elimination. In the first model, backward elimination enter all independent variables into the multiple regression model. So this is basically the same as what we have done in the past by entering all independent variables into the model. In the second model, backward elimination removes the age as the first variable, and then it removes the temp insert, the interaction effect independent variables from the model, and it stops. So it also gives us three models here. As we can see from the last model, actually we have the same independent variables, temperature, insulation, and garage, as those in the stepwise approach and forward selection. So basically, all three different kinds of variable selection procedure give us the same final model based on the variable selection procedures. These demonstrate how to use different variable selection procedures for multiple regression in the heating cost case. Thank you.